This is lesson 8 on page 465 in your books, and this lesson is about function notation. So function notation is all about what does this mean? Spoilers, it does not mean f times x. It means something else. Now, this page has a lot of words, and it's great to read if you learn really well by reading. But this is a video, and it doesn't lend itself very well to just reading this page to you. So I'm going to explain things a little bit differently. So what does f of x really mean? I want you to imagine for a second that you have a vending machine, and it looks like this. And in that vending machine, there is a coin slot over here. And the coin slot is where you have to put your input, in this case, maybe $1. So you have a certain amount of input, $1, and then it's going to output something like maybe a candy. So that's what a vending machine does. It takes an input, which is $1, and it outputs a candy. So I can give this vending machine a name. Maybe I can just call it V for vending machine. And one way to say that is that V of $1 outputs a candy. But what if we change this vending machine so it's a little bit different? Maybe it's a special kind of vending machine. Maybe it's a little bit magical. Because if you put in $1, it actually outputs $2. And if you put in $2, it outputs $4, which is amazing. And if you put in negative $3, or I guess your debt, it will actually also double your debt. So there's a couple ways we could describe this particular vending machine. That it takes in money and then it doubles it. So you could say that this vending machine does like a 2x. You put in an x and then it will double it. We could also give this vending machine a name. Maybe we could call it D for doubling. So we could, in our imaginary world, change what this vending machine does at will. Perhaps this vending machine takes the amount of money you put in, which is your input x, and it adds $1 to it. So we could call this, I don't know, we could just call this vending machine F so that it has a name. So if you put in $4, you are going to get output $5. Now, the way that we would write this is we would say that f of x, the input, is equal to x plus 1. That's a formula on what this machine actually does to your dollar. Another way we could write this in a more specific way is that if you put 4 into the coin slot or the input slot over here, that you are going to get out 5. And the way we say that is f of 4 equals 5. So if you apply the function f to it, 4 turns into 5, or that's what it outputs. So the way I like to think about this is that we can set up this machine f, or this function f, and it has a bunch of empty coin slots in it. And depending on the input that you give into the coin slot, something is going to come out. So in this case, we could input 5, and it would output 6. So f of 5 is 6. F of negative 10 would become negative 9. F of 8 becomes 9. So this notation that we see, f with the brackets, doesn't mean f times 5 is 6. It means the function's name is f, and the piece that we're putting inside the input or the coin slot is 5. So f of 5 is 6. That's what this function notation actually means. But the function's name doesn't necessarily have to be f. We can invent another function, for example, g, that does something different. We can invent this function. So we could say that g of x is equal to 2x plus 1. And again, we can imagine that g of different types of inputs will turn into different outputs. So we could put g of 1, And if we substitute that in, 2 times 1 is 2 plus 1 is 3. We could substitute in 2, and then we could show our work and say that, well, it turns out that that machine will turn your $2 into $5. So not all functions are named f. You can have a function named g. Now at this point, some students might say, what is the point of this notation? Like, couldn't you just say y is equal to 2x plus 1? Yes, you could. And that would mean the same thing in many cases. So this is just a different way of saying this. The reason that we have this notation will become clearer as you study more math. But one thing to recall about this notation that makes it different from this notation is that to use function notation, this has to be a function. And if you're not sure what that means, you need to go back to lesson 7 and think about what a function is and is not. Whereas this does not have to be a function for you to write it as x and y. This can be any relation, not just a function. So function notation is only for functions. So let's do a few examples using this function notation. So they've given us two functions, f of x, this one's name is f, and this one's name is g, and they do different things to their inputs. So the first question asks us, what is f of 3? So what they're asking us to do is put 3 into the coin slot of f and tell me what you get. So we'll go ahead and do that, and we'll substitute in 3. So 3 squared plus 5, which is 9 plus 5, which is 14. Awesome. So we're going to skip over down to this one. This one asks us to input -2, but please input it in G. So we'll do that one. So 4 minus -2. Be careful about that double negative. One comes from the function and one comes from the input. So we're looking at 4 plus 2, which is 6. So we would say G of -2 is 6 and f of 3 is 14. What about this strange example here? They're saying, what's f of 0 minus g of 0? So this is actually not too bad. What we can do is we could do f of 0 in red, and then we'll do g of 0. So you could do them separately and then just subtract the result, or you could do it all in one shot, and I'll just do it all in one shot. So f of 0 means plugging 0 into f. So I'll go ahead and do that. 0 squared plus 5. And then g of 0 means plugging 0 into g. So I'll go ahead and do that. 4 minus 0. If you want to do this all in one shot, just make sure that you're actually using brackets. So they're asking us to take this and then minus that. So if we process this, this ends up being 5 minus 4, which is 1. And so that would be the result you would get from those two functions combined. In the next example, they've given us this function, which is a little bit more complicated. And before I start, I want to remind you that there's another way to write this that you're more familiar with, which is that instead of writing f of x, you could just write y. So this is the same friendly equation that you've seen before, just written in a different way. So keep that in mind as we go through these examples. So the first one asks us to input -3. So we'll go ahead and do that. F of -3 is 5 times -3 cubed minus 2 times -3. So that's 5 times -27. And these two multiplied together is going to be plus 6. And if I put that in my calculator, I get 135, or negative 135, plus 6. And so I'm going to end up with negative 129. So that was easy enough. But the second question asks us to find the value of f when x equals 2. So they've given us the input, and they want us to go backwards. And no, not go backwards. They've given us the input, and they want us to figure out what f is. So all you would do is you would plug this in again. So you would plug that in, and you would evaluate that. And I don't have to do that for you. You can figure it out. Another way to express this is to say, I want the image of 7 under f, which is a very rare way of saying it. They're just asking for the y value. So this is f of 7 that they're looking for. So you could just plug in 7, and you can evaluate that on your own. If they want an expression for f of a, then instead of putting a number into the coin slot, you're going to put a variable, and that's fine. F of a is going to be 5a cubed minus 2a. And that doesn't simplify, so you would just leave it like that. An expression for f of 2x, though, instead of putting a number, you're going to put an expression in the coin slot. Sure, no problem, I can do that. F of 2x is equal to 5 times 2x cubed minus 2 times 2x. Now, in this case, because it is possible for you to simplify it, they would expect you to simplify it as much as possible. So that's 40x cubed minus 4x, and that's as far as it would simplify in this case. So what they're saying is you can put an expression in the coin slot. You just have to plug it right in and make sure to put it in brackets and then simplify it correctly. Class example 3 is a little bit of a challenger just because of the algebra involved. So they're asking us to put an expression in the coin slot again, which is fine. So p of x minus 3 is equal to 4 times x minus 3 squared minus 6 x minus 3. If your algebra is good, you will remember that to simplify this, you have to write it like so. I'm not going to do this because I know you guys are good at doing that. So I'm going to move on to the next question. So example 4 is when we're asked to work backwards. And again, keep in mind that this is another way of just writing it like this. So this expression is really the same thing as this, just written in a different way. And they're asking us to work backwards and determine the value of x, or the input, if f of x is equal to 47. So what they're just saying is that y is equal to 47. Can you figure out x? Sure. So this is 47 is equal to 10x minus 3. And we just have to solve. So 50 is equal to 10x, and x is equal to 5. No problem. The second one, again, solve the equation f of x is equal to negative 23. This is the same deal. This is y is equal to negative 23, so you just plug in for y. Negative 23 is equal to 10x minus 3, and then you would solve for x, and I'm not going to do that here. On class example 5, I think I'm just going to do part C because it's different from the ones before. So they've given us this function, which means the same thing as this. And they've said f of t is 75. So they've given us the value of y, and they want us to solve for t. So what they've done here, how did they just do a switcheroo on us? Why was it x before and it's t now? Don't worry about it. You just put in a different variable. Remember, we can put variables into functions and it's okay. So they want us to find the particular value of t if f of t is 75. So we'll set this up where 75 is equal to x squared minus 5. So we're going to plus 5 to both sides. 80 is equal to x squared. And we're going to square root. When you square root, you are going to get two values that work. If you're confused about this, take a step back to lesson number 3, where they explain why you square root things and you get two values. So there's two values of x that work. X is root of 80, and x is also negative root of 80. They're asking us, though, to answer in simplest radical form. So what you have to do is you have to go hunting for the largest perfect square that will fit into this and change it into a mixed radical. So I believe that the biggest perfect square that fits into root 80 is 16. And 16 times 5 is root 80. If you pull that 16 out, you're going to get 4. So this is 4 root 5. And this is going to be negative 4 root 5. So there are two answers. However, they have given us a restriction here. they've told us that t is greater than 0. Actually, I should have been using t this entire time, but we won't worry about that. They've told us that t is greater than 0. That means that they are not interested in the negative answer. They're only interested in the positive answer. So when I give my final answer, I'm only going to circle this one and I'm going to reject this one because of the restriction over here.